All right, so for the Learning Target 3 warm-up, we're going to look at an old problem, throwing an object in the air. And then we're going to ask a few questions that kind of gets us into the new concepts and new vocabulary. But I've already typed this in. Got to use x's, of course. Y equals, you got to use x's instead of t's. And when you graph it, you get this picture on a 10 by 10 window. That's your standard 10 by 10 window. So go to your table. And then let's answer the following questions. According to the table, what's the height at 0 seconds? All right, what's the height at 1 second? 2 seconds? You get the picture, right? Well, obviously, we're not going to be able to see this thing on a 10 by 10 window because it goes above 10, right? What's the highest it ever gets? That's the vertex, right? So I'll do that scratch work real quick. The h is opposite of b, negative 48 divided by 2 times negative 16. That's 1.5. When you plug in 1.5 in for the function, when you put a 1.5 there for t and a 1.5 there for t and type it in the calculator, it says 51. So your k is 51. It goes up to 51, right? All right, what about question 2? About when does it hit the ground? If you're looking at those heights, about when does it hit the ground? When does it go from positive heights to negative heights? Between x value 3 and 4, it goes from a height of 15 to a height of negative 49. It went through 0, right? So it crosses somewhere around 3 point something. All right. Continuing on, let's make some connections. So about approximately 3 point question mark, 3 point something. How many turning points? That's a new vocabulary. How many turning points does a degree 2, that's new vocabulary, a degree 2 quadratic have? How many times does it turn? 1. And if you'd done that scavenger hunt that I gave you, you'd know the answer to how many turning points a degree 3 has and a degree 4. But if you didn't, it's okay. We'll fill in the gap. But a degree 2 has 1 turning point. Is it a maximum or a minimum? Maximum. Now with a quadratic, it's actually the maximum, right? The highest it ever gets. All right, we're going to add a word today called relative maximum because sometimes it'll be relative. It'll kind of go up and down and make waves, different degrees, and it won't be the actual highest point. Like this one right here, that's a maximum, but it's not as high as this function ever gets because it keeps going up on the right side forever. So it's called a relative maximum. All right, moving on. What would be an appropriate window to view the picture that we just looked at? Well, any x value from negative 10 to 10, that would capture the highest point. It would capture where it hits the ground. But the y-axis, it would need to be negative 10 to something above 51. In this unit, I'm not going to tell you your windows. You're going to have to figure them out. Now, how do we figure out to change that window to above 51? You look at the table. And you start looking at what's it doing. What are the numbers doing? When does it hit the ground? You start analyzing the table and you come up with my y max needs to be, I don't know, 60, something like that. Okay? So you'll have to figure out your own windows in this one. All right, this is the really difficult part for most people, the increasing and decreasing intervals. Pick a word problem to start with because it makes more sense. At what time, this is the real, part about the warm-up, okay? At what times would you say that the height of the object is increasing? When is the object that we threw, when is it increasing in height? Think about that. I'll go back to the table. I'll scroll this back up to the information that we found earlier. That's modeling an object that's flying in the air. When is it going up? From 0, from when it started, when? To 1.5. Now notice, this is important. What did you just logically say? You said from 0 to 1.5. You said x values. t values, time. You said x values, but what were you looking at? The y values, okay? You said x, but you were looking at y. All right, so it is increasing from 0 to 1.5 on this word problem. When is it decreasing? From 1.5 to when? To about 3 point, we'll say 3.3, because that's what it is, to 3.3. And you remember you could find those numbers left bound, right bound, right? Okay. All right, that's about all we can squeeze out of an old problem. Our increasing and decreasing intervals are going to be from infinity to negative infinity to, from negative infinity to positive infinity. So it's going to be a little more complicated. But the important part is this. What did you say for increasing x values? You said x values, but you were looking at the y values. All right, that's the important part right there. All right, I'll stop that video and record the next